in listen-only mode.
Hello, and welcome to the Energistics WITSML version 2.0 Release Candidate Overview webinar. My name is Nicolette Ross, and I will be your moderator today. I would like to start this session with a few housekeeping items. For audio, you may use either your telephone or a mic and speakers. Please note that all attendees are muted. At the end of Jay's presentation, we will have time for questions and answers. You may submit your questions throughout the talk by using the Q&A section of the session toolbar. If we run out of time, we'll try and follow up on all unanswered questions. This webinar is being recorded and will be available on the Energistics website within 48 hours. You will receive an email with that link. For your convenience, we have the presentation slides added to the session toolbar under Handouts. You may download them during the session. At the end of the webinar, there will be a very brief survey to let us know how we did. We would appreciate you taking the time to provide us feedback. Our session today will run about 45 minutes with Jay presenting, and then we'll have about 15 minutes for Q&A. Before I introduce Jay, we have a few questions that we would like to ask to find out a little bit about you. Our first question, has your company implemented WITSML? If you would please take a moment and answer that, I would appreciate it. As you can see from the results, 84% of you said yes, that you have implemented WITSML. 6% have not, and 10% are not sure. Our next question, if you answered yes, that you have implemented WITSML, what versions are implemented? Please check all that apply. And there's results for that question. As you can see from this, most people have implemented version 1.3 at 76%. 73% have implemented version 1.4, with 27% of you implemented version 1.2. We have one more question we'd like to ask. Do you work with WITSML today? %of you say yes, you are using WITSML today, and 21% of you say you are not. Thank you so much for taking the time to answer our questions. We appreciate that. Now I would like to introduce Jay Hollingsworth. Jay is the Chief Technology Officer for Energistics. He has a BS in Chemical Engineering from Tulane University in New Orleans. In addition, he attended graduate school in computer science at the University of Texas in Dallas. As his career advanced as an environmental and process engineer, he always focused on technical computing, first as a consultant and then for 20 years at Mobil Oil. After leaving ExxonMobil, Jay spent time in Landmark's data modeling group before moving to Schlumberger, where he spent 10 years as the person responsible for the data modeling group and was the portfolio manager for the seabed database technology. Welcome, Jay. I will now turn it over to you.
Thanks, Nicolette. I hope you can hear me okay.
Yeah, you come through great.
Okay, great. So thanks everybody for joining the webinar today. So this is what we're going to cover this morning. Want to have a couple of brief words about Energistics, and then WITSML in general, then talk about the next generation of all of our standards, followed by a deep dive into what's contained in WITSML 2.0, and we'll close with a discussion of what's in the release candidate itself for people who may not have downloaded the zip file already. So, who's Energistics? Hopefully you guys all know who Energistics is. Hint, we're not a vendor, we don't have anything to sell. Energistics is a nonprofit organization driven by our members, and we focus on developing data exchange standards. Energistics celebrated its 25th anniversary last fall, and many of you actually came to our 25th anniversary celebration, which was a pretty nice evening. And our membership consists of basically everybody. Not every company, but every type of company. We have large independents, we have national oil companies, and big international oil companies, software vendors, systems integrators. We have quite a few regulatory authorities, and we have members of Energistics who are other standards bodies. We don't make up the standards ourselves. The standards are made by our members. The Energistics staff simply guides that work, has a website and a location to store the things, and makes them available and encourages adoption and tries to foster people to be able to use the standards. So in short, the standards are made by our members or by the industry, and they're for the benefit of the industry. Our members are distributed around the world, and you can see the distribution of operators and oilfield service companies, solution providers, and so forth that are our members. And this is a traditional logo slide. You can look for your company on there. If your company's not on there, you might like to give us a call and join this community of people that are the ones who set the direction for the standards of in the oil and gas industry. The standards Energistics has, we have 3 flagship standards. WITSML, which we'll talk about today, obviously, but we have 2 other standards. We have PRODML, which is a standard for transferring production and surface-related information. It's widely used in regulatory reporting and volume reporting. And we have another standard called RescueML, which is a standard for moving earth modeling information among applications. And we're pretty excited about the new release of RescueML, but we'll talk about that at a subsequent webinar. But we're here today really to talk about WITSML and about drilling. So WITSML has been around for a long time, over 15 years, and the version which is coming out is version 2. So it's a pretty much of a sea change in the way the standard is, but WITSML has been widely used and there's been a tremendous amount of value gained for the industry in the use of WITSML, and these are the use cases it was really intended to kind of satisfy. It began for consistent high-quality transfer of drilling data, and it became expanded over time to be really any wellbore related information. The dominant use case for it has been data transfer from the field into a real-time operations center, or from the field into a running application for doing something like geosteering, those kind of things. The kind of data it transfers are grouped together kind of in 3 large areas. You have typical things which are reference information that doesn't ever change, like the well and the wellbore, and you know, what's the makeup of a bottom hole assembly, and those types of things that don't really change as you drill ahead. Then there are 2 kinds of objects that we move data in that change over time. We call one category of objects growing object, and those are things that change continuously as you drill. So that's obviously things like hook load, weight on bit, rate of penetration, any sort of logging information, LWD kind of data. Also the trajectory changes as you drill ahead, and the mud logger gathers mud log information continuously as you're drilling ahead. So those are what we would call a growing object. We also have a series of objects which are sort of snapshots in time. So you can think of a daily morning report, which is a drill report, or an operations report, which is really more about what materials are on hand, who's on the rig, those kind of things, a fluid analysis report. And those are snapshots in time that just change from time to time. And the use case for WITSML also includes moving well-related data between applications. And we're seeing a real increase in people wanting to use WITSML not to move real-time data from the field into the office, but well-related data between applications. And we'll talk about that a little bit later. And as I said before, the real-time availability of those drilling operations. So in addition to transferring the technical data, you also have the opportunity to move operational kind of data in real time so that that's available as well. And those are the use cases that WITSML, all the previous versions are intended to satisfy. And you guys in the poll earlier, some of you are still on WITSML 1.2, which is kind of odd, but WITSML 1.3, 1.4 has been out for 5 years, I suppose. So it's been, those use cases have been satisfied by those versions. What is WITSML exactly? Well, WITSML, as it's produced from the membership of Energistics, is two things. It's a set of XML schemas that define a group of things that we can move, and we call those objects. So a well would be an object, or a description of the wellbore would be an object, or a log would be an object, and those things are delivered as XML schemas. And that's the definition of those types of information, and then XML is the transport mechanism that's used to move that data around. But in addition to these object definitions, WITSML also includes a programming interface, an API, application programming interface. And this defines the behavior of the server that exists in the WITSML world. The API is not very complicated from a programmer's perspective. It really only has a few functions. You add something to a WITSML store, or you get something for a WITSML store. You can also update something in the store or delete something from the store. But the prior generation of WITSML expects there to be a server, and you're constantly interacting with this server to either put data into it or get data out of it. And what we find as a common implementation pattern of the current generation of WITSML is that there are a series of stores. So you'll have a WITSML store that's located on the rig itself someplace, that's gathering information from all the different contractors that are on a rig. Then that data typically would move from the rig site aggregator store to a different WITSML store that's located in one of the service companies. So without going into the trade names for those things, there are many of the service companies that offer this monitoring service. So as a user, you don't connect directly to the WITSML store that's on the rig. You connect to the WITSML store that's in the office of the service company. And then some oil companies then maintain a WITSML store inside the company itself. So the data actually makes several hops as it goes from the rig to the rig site aggregator, to the service company WITSML store, to the WITSML store inside an oil company, and then finally the end user picks up the data from the WITSML store inside their company. So this business of the stores means that there's quite a latency, sometimes a delay, between the time a sensor senses a piece of data and that data is made available to a user. But now, times have changed since the time of the requirements gathering for WITSML 1.4, or the previous generation of WITSML, and we have some new requirements. So one of the requirements relates to the thing that's in vogue today about big data and analytics. People want to be able to gather a lot more information. People don't want to throw anything away. People want to be able to take this information in a sort of a semi-structured way and preserve it so they can analyze it later. But they also want to be able to analyze this data in motion before it's even stored in any kind of a data store. So having a sort of a computing infrastructure that allows you to watch this data as it moves by is an important requirement on transfer standards today. The second big requirement, obviously, is speed. People want to be able to get a sensor reading from the rig back to an expert in their home office as quickly as possible. So the first requirement means we have more data, but the second requirement means we also need to move that data faster. Faster in the terms of how many bits per second, also faster in the delay between the time a sensor reading happens on the rig and it's visible in the office. But in addition to this real-time series of requirements, there's a lot of pressure from the WITSML community to be able to satisfy much broader workflows. So the application-to-application workflow is now very important, especially in some of our members. If you think about it, if I'm going to move data about a well from application A to application B, how do I do that today? Well, I can write out an ASCII file. I can have a consultant configure the ASCII loader in application B and load that ASCII file. I can try to make that a process. I can come up with a book that describes the format of my ASCII file so that my company can always use the same format ASCII file, or maybe I'm going to try to use an Excel spreadsheet with CSV files. But the truth is that there's a perfectly good standard that you could be using to move that data, which is the WITSML well and Wellbore. So why not just use that standard as a standard way to move this kind of data between applications? And we have some members that are working on exactly that today. Another workflow is things that are based on files. So historically, WITSML data were never really written out as files. You asked a server to give you some information, and the server responded with the information you asked for in the form of a little XML document. But now we have workflows where people actually want to write out files and save those files for subsequent loading or for archiving or whatever, which leads to the next workflow. There's a really important workflow for WITSML now that relates to archiving data. There isn't a good format other than a WITSML to be able to say, here is all the real-time data from the drilling of my well. Now I'm going to archive that away so I can load it later for analysis. Or maybe for some sort of Sarbanes-Oxley or whatever legal requirement, I want to be able to preserve all of this data from the drilling of my well, and WITSML is the perfect format for that. Finally, the last workflow, and we'll talk about this a little bit later, is expanded metadata. So either with the real-time data that's streaming or with the more data that would come in a file, there's a desire on the part of the WITSML community to have much more information about that data. What's its quality, who took it, when was it taken, how many servers has it been through. All this kind of information has been not lacking exactly, but difficult to access in the prior generation of WITSML. So the new version of WITSML is intended to cover that workflow as well, or that requirement as well. So like I said before, Energistics is stewarding 3 flagship standards on behalf of the industry: WITSML for well and drilling data, PROTML for surface and production kind of data, RescueML for earth model data. All of these standards are moving to a version 2.0. RescueML 2.0 has been out for a year. 2.0.1 came out a while back, and version 2.1 will be coming out, we hope, sometime later this year. PROTML will have its version 2 this year, and WITSML will also have its version 2 this year. So one of the things that we're doing is having some commonality among these version 2 standards, and these statements that I'm about to make really apply to all of them, but we're going to focus on the WITSML aspect of it. But the things that are different and how they're better than the previous one, and I'll have a little slide for each of these points. The first point is that they're integrated one with another. They're oriented on programmers, supporting new workflows. There's now training available, which Energistics didn't historically have, and there's a lot of new underlying technology underneath the new set of standards. So you're going to see this, the results of these things in the WITSML V2.0 release candidate. So I wanted to cover a little bit of this. All of those standards are now integrated. So without having gone through the long history of WITSML and PROTML, most of you know that those standards weren't developed initially internally inside Energistics or its predecessor organization, POSC. They were developed by other organizations, which then came into Energistics to steward those standards. Well, since they grew up independently, they somehow are in ways they're different one from another. Well, it was clear that we needed to have the second generation of standards be prepared in such a way that it could be thought of as one large standard. So if I have WITSML and I need to suddenly grab a well test from ProtML, I can grab a well test from ProtML and move it along with a WITSML Wellbore and well log transfer. So all of that cross-ML integration is covered now under the second generation of the standards. And in addition to that, we've taken a fresh look at what other standards exist outside of Energistics to see where they could be incorporated into our MLs. As it happens, the only one that's relevant to WITSML is the use of ISO 19115 metadata. So that's the only one which is particularly relevant to WITSML. And I'll mention that again in a few minutes. Oops, my old drawing is still there. All right, programmer-oriented. So in thinking about the next generation of standards, the members thought about this and were thinking about who is the person who actually uses the standards. Drilling engineers care about the details of what data is being moved from the field into the office. Managers care that the workflows that they're trying to enable to make money for their company are being covered by the transfer standards. But the people who really use the standards are computer programmers. And the style of the standards and the documentation that came with the standards wasn't necessarily really oriented towards programmer productivity. Well, that's changed. So now in WITSML 2, V2.0, you'll find stuff that's there to make programmers' lives easier. So the XML schemas are developed in a more convenient style, and I'll show a small example of that in a few minutes. Those of you that aren't programmers will just have to pay not attention to that slide. The documentation is going to be very much better. The documentation for WITSML historically, WITSML 1.4 had actually good documentation, especially for the API, but there never was documentation about all the data objects themselves. So there's going to be much improved documentation for the developer community. Another thing which is a major change from the past is Energistics is now delivering community contributed source code. So we'll talk in a few minutes about the ways that source code is being delivered, but there's actually stuff out on our Bitbucket site that you can go and grab different kinds of source in different languages, and I'll talk about that a little bit later. But that's a pretty major change from Energistics' perspective. And finally, we do have a dev kit that was contributed by ExxonMobil, and Energistics now maintains that going forward. So if you're a developer, there's actually a starting point that you can grab this off of our website or out of NuGet and then march on ahead and developing against the standards. I've talked a little bit about the workflows. So previously for WITSML, there had to be a server. That was the point of WITSML, was you added something to a store and you got something from a store. In the new workflows, there is no requirement that there be a server at all. The thinking that we have about it is more that there's a producer of data and a consumer of data, and you assert those roles as they're needed in the context of a particular data transfer. So you can have a server if you'd like, but we have these serverless modes now. We've also put a bunch of stuff into WITSML to support data management workflows. And I've mentioned the archival workflows. We have some detailed stuff, which I'm not going to go into all those details today in the short time that we have for this webinar. But we have quite a bit of metadata added into the WITSML standard to allow you to track where data was produced, what's happened to the data since it was produced, the quality of the data, and I'll talk about the data quality assurance a little bit later. But we have a special new part of WITSML that's really all about carrying data quality related information along with this with the normal technical data. Training is something that's new in the second generation of the standards, including WITSML. We began conducting training last year, even though WITSML 2 wasn't yet out. We've begun offering training. Since last fall, we've given 3 classes to private companies already. We gave a public class, a successful public class earlier this year on WITSML, and we'll be scheduling further public classes as the year goes on. And we're also intending to do webinars like this one to try to get the word out to people that the standards are out, here's what's in them, and help people to get started adopting the standards. So, specifically about WITSML 2. What's in WITSML version 2.0? So WITSML version 2.0, when you look at it, it seems largely familiar. It's continuing to be based on XML, and the WITSML spec continues to have these data objects, and they're still in XML. But there's fundamental changes. One of them is the fact that this new version of WITSML is based on what we call our common technical architecture, which we'll go into some detail on in a minute. But that's the underpinnings of the new technology, the integration across the MLs, all of that stuff we call our common technical architecture. The old API, which was based on SOAP, which is a web services kind of technology, is deprecated. And we have a new API, which is called ETP, the Energistics Transfer Protocol. WITSML 2.0 is actually going to be based on version 1.1 of ETP. Version 1.0 of ETP has been out for quite some time, so this is not a brand new thing. But this API replaces the old SOAP API. The XML itself, while it will look somehow familiar, is very much simpler in its structure. We found that some developers felt that the structure of the XML schemas were too complex, and so they've been simplified to make everybody's life easier. And as I mentioned before, WITSML 2 will have documentation on the data objects, which didn't exist previously. So what can I do as an engineer, forgetting the IT stuff? As an engineer, what could I do that I couldn't do before? You know, I understand that my programmers will be able to program against this more easily, but what can I do? The number one thing is true streaming. So in WITSML, there's no more need for a server. So you simply point yourself to a sensor that you'd like to get some data from, and the data begins streaming to you. You can subscribe to a particular sensor and say, if you ever get any new data, let me know about it. So it's true streaming, low latency, meaning there's no need to go for a hop from one server to another to another to another. The data just comes directly to you. And there's security. So we've been putting a lot of thought and working with the security departments of some of the operators who are our members to make sure that this streaming that happens is as secure as it can possibly be. So true, secure, low latency data streaming. The second thing you couldn't do before that you can do now, track quality. So when we talk about data quality, it always puts a different picture in people's mind. If I say data quality, whoever you are, it drew a little picture in your mind. So what the group decided to do was to say that what we will do when we transfer data is transfer along with the data a statement that the piece of data I'm sending you conforms to a rule that you created in advance. Or maybe the data I'm sending you fails the rule we created in advance. Some rules that people make on data are obvious from the data itself. So if I tell you a percentage should always be between 0 and 100, and I send you a value that's 110%, well, it obviously falls outside that range. But there are some kinds of rules you can't tell from the data. So there are important rules about calibration. When was the last time this instrument was calibrated? There may be a rule that my well location needs to be surveyed by a land surveyor within 30 days of completion of the well. That's a personal policy that my company might have. You can't tell from the data whether that's happened or not. So with the new generation of WITSML, you have the capability, once you've established those rules in your company, to transfer along with the data a statement that the data I'm sending you either conforms to or fails to conform to some of those rules. So this is really important for the data quality management processes that are going on in pretty much all the operators now. And there are new features in the XML themselves. So we have a new Wellbore Geology model. The stimulation and cementing models have been completely redesigned, and they cover not only how did the cementing job go or how did the stimulation job go, but you can also convey the design of those jobs. So you can send to the field a document that describes how the job is supposed to go, and then the field can report back to you, this is how the job went. So these are some pretty important features that are added to WITSML, again, at the behest of the community that developed the standard. From an IT perspective, WITSML 2 allows you to organize channel data, which we think of as logs. That could be logs like gamma ray and sonic. That could be channel data, could be a channel like hook load or rate of penetration or weight on bit. You can now organize that data pretty much any way that you like. You can have multi-dimensional data. All of these things are now supported in WITSML 2. And we have the possibility to chase through multiple generations of those servers that I talked about. From the IT infrastructure perspective, there's a couple of interesting things. You know, a lot of the network traffic that happens with WITSML is a client application constantly asking the server, if you have any new data, do you have any new data, do you have any new data, do you have any new data? Now that polling traffic is eliminated, because you simply subscribe to a channel, and then when there's data available, it comes through the WebSocket stream. So the network traffic should be reduced for this polling, which opens up the bandwidth to be able to stream more information faster. So this is what WITSML 1.4.1 can move. This is it should be 27. Yeah, 27 objects in WITSML 1.4.1. So people who are familiar with WITSML should be familiar with this list. Here's what happens to these objects in WITSML 2. Some of the objects have been eliminated, largely because they were felt to be unused, and the community didn't want to have the expertise to try to move them forward. If you see something on the list in gray that you think is really important to you, be sure and raise that up through your representative at Energistics, and we'll see about engaging a group to bring some of those back into WITSML. The objects in red have been basically completely redesigned. So that functionality still exists in WITSML 2, but it's in a different form. The ones which are in the sort of the dark brown, those are largely unchanged. They're simplified using patterns, but the content of them is largely unchanged. And then coordinate reference system is no longer WITSML specific. It's moved out into a common area so that it's visible across WITSML, ProdML, and RescueML. So it's no longer local to WITSML. And this is the list of the WITSML 2.0 data objects that are currently in the release candidate. And I didn't include on this list the objects from the completion world. So we also have 4 data objects that relate to completions. They're not on this list, but they're also carried forward largely unchanged from the previous version. So I'll give you a chance to look at this list and then move along. So one of the things you could have noticed is that the WITSML 2.0 data objects start with capital letters, and the old ones started with lowercase letters. It turned out that the different standards in Energistics used different naming conventions for these things. So now all of the Energistics MLs have a new naming style, which is this Pascal style. The data objects themselves, we've improved some of the attribute names to make them more obvious to people what they are. The data objects, as I said before, will have better documentation. So we're going through one element at a time and making sure that there's something meaningful as a documentation for each element. And The last two are really sort of pretty much IT focused. If you're a developer, you may know what a substitution group is. It's a kind of an obscure XML schema feature, but we did keep that moving forward. And we also take advantage, if you're a developer, much more of the inheritance that you can have inside XML schemas. So I guess this is more of a developer-y kind of slide. The structures in the XML schemas are much simpler. There's no plural root. There's a lot of the stuff that used to be in every WITSML XML schema object is just been eliminated to make things simpler. There's a lot fewer files. Before there were around 200 little files in the folder of the schema. Now there's probably around 50 files that are in the directory now. We've also created a new place, something called Common. There's a whole bunch of the files that are in WITSML that contain sort of basic information about what a floating point number is, or what an integer is, or what are the enumerated values of a well status, those kinds of things. These have all been moved out of each of the individual standards into a common area, so they're shared across WITSML, ProtML, and RescueML. So those things are no longer local to WITSML. But it does mean that if you get the WITSML release candidate zip file and you unzip it out on your disk, you'll see there's a folder called Common now, and because WITSML needs to have this common stuff in order to work, the same as if you had ProtML or RescueML. Each of them needs this same common area. Now in the last few minutes I'm going to talk about some of the underlying technology, the new technology that's living underneath them, and I tried to think of it of a picture for alphabet soup. We're not going to actually talk about all this technology because WITSML doesn't use all of it. But the most important bits that WITSML uses are the XML schemas and this new Energistics Transfer Protocol. So one thing that is important that's changed inside Energistics is it used to be all these XML files were sort of generated by hand, and it took quite a long time to get them generated. Now the community is able to specify something in UML, which is a graphical modeling language, and we create the XML schemas from that. So it's gone from months to minutes that it takes the WITSML community to actually propose a change and see it appear in the XML schemas. So that's a pretty important workflow improvement for the people who are actually involved in creation of the standard. XML is the same. If anything, the new version of WITSML eliminated some of the XML techniques that WITSML previously used because those XML techniques were poorly supported by the programmer tools. So we've actually simplified the way we use XML, but it's plain old XML. I do want to talk about the Energistics Transfer Protocol. So the WITSML data objects are the carriers of sort of the static information, the well and the wellbore, or the growing objects like a trajectory or a mud log. But the real-time data, the benefits are coming from this new Energistics Transfer Protocol. It's a new data exchange specification that's specifically about moving real-time data between applications. One of those applications will be a producer of information, and another one will be a consumer of data. If you choose to make the producer a server, then you can have a server. If you choose for the producer to actually just be a sensor on a drilling rig, then it is the producer of data that you can consume. ETP is not only going to be delivered as a specification like a book, like a PDF document, but it's actually being delivered as code. And as we'll see on a slide in a couple of minutes, we have code in C#, C++, Java, JavaScript that's available for people to download and put to use. We also have a couple of sample implementations that have been contributed by some of our members. So this is a completely different approach than Energistics has historically had. The protocol, when we call it a protocol, what it really is, it's just messages. So I have as a client, I send a little message to a sensor saying, am I allowed to talk to you? And the sensor comes back and says, yes, you are. And I ask the sensor what data it knows about, and it tells me it knows about hook load and ambient temperature, and then I ask the sensor to begin sending me all of that data, and then it just begins streaming data to me. So it's all about little messages. And there's lots of different kinds of messages, and so they're grouped together into what computer science people call protocols. ETP was originally developed for WITSML, but in fact it's going to be used for all of the MLs, and we're starting to get some interest actually even outside the oil and gas industry. You know, on the bottom you can see this Industrial Internet of Things, the IIoT. You know, you hear about this IIoT word, you know, in the press, and the truth is we looked at all of the existing protocols that are out in the marketplace today, including the two newest ones, which is Distributed Data Services from the Object Management Group and something called NiFi, which is an Apache project. But none of them have the features that the oil and gas industry needs to be able to move real-time data effectively. So Energistics, by having created this transfer protocol, is starting to gather some interest actually outside of Energistics. So the protocols, I'm not going to go into this detail today, but basically we've grouped these messages together into 8 little groups, and you can read this or you can download the presentation after we're done and learn more about this. It uses the mechanism ETP uses to communicate is something called WebSocket. WebSocket is a normal internet protocol. We're not inventing that wheel. It's something that's known to the IT community, but it's interesting that it allows communications in both directions. Because if you think about it, if I'm going to speak to a sensor and ask it to send me data, I have to be able to communicate to the sensor and find out what it knows about. So there is traffic that goes back and forth before the streaming starts. We use an Apache thing called Avro to be able to put the data into the ones and zeros that travel along the wire. This is not so interesting to a general audience. We also use a technology called JSON, JavaScript Object Notation, for encoding the data in this Avro serializer. And I said that we're also we're making source code available. So we use something called Git, which is a really commonly used IT way of storing source code or documents and other things on the internet. Some people use GitHub. We happen to use something called Bitbucket, not Bitbucket, but Bitbucket. And again, you can find more about this either from us or from information that's inside the zip file. So the source that we deliver is not only available through Bitbucket, but if you're a developer, we are using other distribution methods to be able to push this information out as easily as possible to developers. The source actually includes, as I said before, little sample running ETP servers that you can download. Bill McKenzie from Chevron put one on an Arduino, which is like a Raspberry Pi, so you don't need a really big, huge computer to run these things. And again, all this code is contributed and it's maintained by our members. So finally, if you come to the Energistics website and you get the release candidate file, what you're going to find in the file are the XML schemas themselves, which is the standard. The statement of the standard is what's in those XML schema files. Another thing that I didn't mention before, but that's a custom of the WITSML community, is whenever a new version of WITSML comes out, an upgrade mechanism is provided to go from an old version of WITSML to a new one. And so Robert Shaver from Halliburton has put a lot of work in creating transformations that will go from WITSML 1.3.1 to 2.0 and WITSML 1.4.1 to 2.0. You don't have to go via 1.4 to get to 2.0. You can go directly from 1.3 to 2.0. A couple of the objects in WITSML are so different that he couldn't actually make a reasonable XSLT transform, but it uses a technology called XSLT to do that. But you'll find those transforms described in the zip file. There is sample data that's in the zip file, but truthfully that sample data is simply the old WITSML sample data that was upgraded. Recently, Statoil has contributed and Kongsberg has made available 5 wells which have quite a bit of data in them, and those files are currently available through Kongsberg, and we'll be making those available on our site, and we'll be putting the word out as soon as that information is available. They gave us the files in 1.4.1 format, and that data will have to be upgraded to WITSML 2.0, so that's why we're not just making it available instantly. I told you that there's documentation in the release candidate. As the review period carries along for the release candidate, we intend to improve that documentation as we go along, and whenever we update the documentation, we'll kind of let people know. But whenever you go download something, you may find an improved version of the document. And finally, inside the release candidate, there is a feedback form where the technical team has reviewed the model pretty extensively, but we're now in a public review period, so there's a feedback form, which is a little Excel spreadsheet. It's also in the zip file, and we're looking for those comments to be back by June 30th, so we can start the work to fold all those, whatever changes result from the comments, back in to make a timely release of WITSML. So that's kind of it for the formal part of the presentation this morning, and I guess I'll turn it back over to Nicolette to let me know if there are any questions. I haven't been reading the chat, but you can tell me what the questions are, and I don't know whether we open it up for people to ask questions via audio. Nicolette, I don't know how that's going to work.
No, we'll take the questions via the toolbar, the question toolbar.
Okay.
So thank you, Jay. That was a great update on WITSML version 2.0. I'm sure everyone's looking forward to using it when it becomes available. So just as a reminder, there's the question box in your session toolbar. So if you have a question, please submit it now. We do have a few that have been submitted. The first one is, any plan to move or support JSON?
Yes and no. So JSON, we use JSON for the real-time streaming part. There's no reason in the real-time streaming to have a lot of XML tags like WITSML 1.4.1 did. So we use a large JSON array to send the logs today. But the community at large isn't ready to replace XML with JSON for the static things like a well and a wellbore. The main reason being that the first step that a developer typically would do when receiving a WITSML document is validate against the XML schema to make sure that what I've received is a valid WITSML document. And right now there is no prevailing JSON schema standard. There is a JSON schema.org that's working on that. The last time I checked, they were up to version 6 of their draft. But the IT community is just not yet ready for JSON to totally replace XML. But we're keeping track of it. And like I said, where JSON is appropriate, we're already using it in ETP.
Okay, thank you. Next question. So can now from WITS, can we have WITSML directly without converter or server?
WITS isn't XML, so you will always have to convert from raw WITS into XML. WITS is also not JSON. So as I said, the kind of channel data that WITS uses isn't a valid JSON array. So you'd still have to put square brackets and commas and things in the middle of a WITS stream for it to be a valid WITSML log. So you still have to have a converter of some kind. Not a very heavyweight thing, but it still have to have a converter of some kind.
Okay. Next question. No love lost for most emissions, but how would a sidewall core be documented in WITSML version 2? just conjecture, but sometimes they're performed?
So the sidewall core object was less about the taking of the sidewall core and more about, I think, the contents of it. But I haven't actually looked at that object in a long time. If there's interest in bringing the sidewall core object back, we'd be happy to have a group of people who want to look at that. But I guess at this point I would just record an activity that I did a sidewall coring operation at a particular depth. Just record it as an activity. Other people might have some other ideas, but off the top of my head, that's what I would say. But
Okay.
whoever asked the question, if you're really interested, again, the only reason that they weren't carried forward was because the technical team didn't have the people involved who were interested in that topic. But if you're interested, talk to your rep on the technical team and let's get a little group together and bring it back.
Okay. Next one. My years in typography and printing confirm the readability of the title case capitalization that you call Pascal style. So I don't know if that means the Pascal programming language or not. I took Pascal for a month once and don't remember.
Yes, Pascal style is sometimes it's called upper camel case. It means the first letter is initialized. So Pascal refers to the Pascal programming language, not Blaise Pascal, the philosopher.
Okay. Here's another one. Can I know more about DRLG report object?
Yes. Depends on what you'd like to know. The drilling report object is largely unchanged from 1.4.1. There were some small additions to the drilling report object that were added at the request of an organization called EPIM in Norway. In Norway, they used the drilling report object for some cross-partner reporting purposes, and they had found some things that they felt were missing. So we added in the things that were asked for by this organization in Norway. But other than that, the drilling reporting object is pretty much unchanged.
Okay. This one's a comment. It's music to my ears that programmers said the structure was too complex. Let's hope this speeds adoption of the standard.
We hope so. Thanks for the comment.
Next one. Does ETP implement its own redundancy reliability mechanisms, or does it rely on existing protocols like TCP/IP?
No, it relies on the TCP/IP stack for that. Right. It's basically, currently it's WebSocket, which is based on HTML5, and that's all based on a regular TCP/IP stack. We have added some security-related things using Java Web Tokens for authentication, but we rely on the stack for that other stuff. And WebSocket actually has some of its own redundancy content built in.
Okay. Next one. NPM or NPM?
Good question. I may have misspelled it. It should be NPM. I may have had it wrong on the slide.
Okay. Does someone need to be a member of Energistics to access the bit bucket?
No. Well, I say that currently for ETP, no. ETP is open to the public. The release candidate, the zip file of the release candidate of 2.0, you don't have to be a member to have that either. You just come to the website and you download the release candidate, which is a zip file, and opens up on your machine. Energistics members have live access to the Bitbucket repository that will show newer versions, updated versions of the release candidate. So as people are reporting little problems in the XML schemas, we're fixing them. We're trying to fix them as we get them. And so members can connect to a private Bitbucket repository that enables them to see the currently corrected version of the release candidate. But to the public at large, it's not pointful for us to expose partly completed work like that. So typically we don't for the MLs. But for ETP, that's completely open to the public today.
Okay.
The same, by the way, for the dev kit. I think if you want to download the dev kit doesn't yet include WITSML 2. So, but if you want to get the dev kit for the older versions of WITSML, that's also available to the public. You don't need to be a member.
Okay. Next one is a comment, just an FYI. Bitbucket is banned in our company.
Yeah, I know about that. So that must be a Schlumberger person. Yeah, for some reason, Schlumberger blocks access to Bitbucket, and so we've actually had some requests to try to mirror our Bitbucket repositories onto GitHub or something that Schlumberger doesn't really block. But whoever is making that comment, if you're trying to get access to something, send me an email offline, and we'll figure out another way to get you whatever it is that you're looking for. But if what you want to do is see the release candidate, you can just download that zip file from the website. But it is indeed true that, and there may be other companies that do a similar thing, but I do know for a fact that Schlumberger blocks Bitbucket.
Hey, will the stat oil Kongsberg data be made available in 1.4.1.1 as well as 2.0?
Yes, it's available in 1.3.1, 1.4.1.1, and then when we transform it up to 2.0 and do whatever manual stuff we have to do, it'll be available in 2.0. But we just got it yesterday, so it's available today. If you have the ability to sign into Kongsberg, then you may need to ask them for a separate, to email Kongsberg and ask them for a separate allowance to be able to download that specific data. But within a matter of a few days, we'll have the ability to get that somehow from Energistics in the 1.3.1 and 1.4.1.1 formats. But and I keep talking about Kongsberg. Statoil is the one who's contributing the data, so they really deserve the credit for having gone to the trouble to contribute the data. But they made it available through Kongsberg because, again, in the old WITSML way of looking at things, you get data by asking for it from a store. And since Kongsberg is Statoil's vendor, Kongsberg was making it available, but they've made it available to us as just files, which we expect quickly other WITSML server vendors to pick this data up and make it available on their test servers if you have access to their test servers.
Okay. The next question, what is the plan for how to implement the data quality checks?
So the data quality checks, it's an interesting, slightly larger question. There are several companies who are our members. I mean, the data quality group was largely led by BP and Chevron, and they both have organized efforts to define data quality rules in their company, and once you've gone down the path of declaring those data quality rules, then the new version of WITSML simply allows you, when you transfer data, to assert whether that rule is conformed to by the data I'm sending you or not. One thing we won't do as WITSML is say I refuse to send you data that isn't good, because a lot of times that's all you have. And if the rule that's failed is I have a rule that the instrument has to be calibrated every 30 days and it's been 35 days, I'm not going to fail to send you the data from a drilling rig because a rule like that has failed. So we send you the WITSML will transfer the data and simply tell you whether the rule that you've defined in advance is passing or failing. But your company would need to have embarked on a data management strategy to actually try to keep track of the quality of data and to decide in the context of your company what good quality data means. So a WITSML can't do that. WITSML can simply convey along with the data a statement whether the data conforms to the rule you've created or not.
Okay. I think we're going to take one more question, then we've run out of time. how can we get help from your company in the future?
From Energistics, I suppose you mean. So there's lots of avenues for that. There's I mean, the best way is to join the WITSML technical team and participate, in the development of the standard. And once you're part of the group, then it's a networking opportunity. You'll know the people that are the experts in various companies, and our members are really good about answering questions from each other, when it comes to those kind of things. If it's something that's more specific, you can send us an email and we can answer questions. We are going to have webinars like this. We have public training classes that you can come to. If you work for a company that would like to have a specific training for your company on WITSML or any of the other MLs, we've begun to do that as well. So there's quite a variety of ways to get help from us.
Okay. Well, thank you, Jay, very much. We have run out of time. We will try to follow up. We still have a few questions that haven't gotten answered, so we'll try to follow up with those people specifically. Thank you all for taking time to spend an hour with us today. Our next webinar is scheduled for May 24th, and it will be on the value of standards. Invitations will be sent out very soon, so watch your inbox for that announcement. And thank you all very much for attending today. The session is now ending.